Are you able to hear me?
Yes, sir.
Okay. So in the last class, we have seen about the boosting algorithms in machine learning. So today we will see AdaBoost. So it is a short written for adaptive boosting. So it is also a boosting algorithm, which is an ensemble algorithm that can be used in classification as well as regression tasks. And it is a supervised algorithm which is used to classify data by combining multiple weak or base learners, example, decision trees into a strong learner. So here it works on weighting. So one different concept is applied here. We will be using weights for this algorithm in the training data set. And based on that, we will be getting the result. One simple example I will show you how it is calculated for a given data set that we'll see. So I've already told you that original data is there and that data is weighted, and after weighting we will come to know about the prediction and we will get the result. So here one concept of weighting is used which is applied to its predecessor based on the classification and misclassification that we will see with an example. We first share. So are you able to see it? My screen I've shared. Is it visible to you? Okay. Okay. Just we are taking one training data set which consists of six data instances. I will write here. So, how a particular training data set is uh, mathematically computed. So this we will see here in steps. Then you can get the idea how this AdaBoost ensemble learning is used. We have here CGPA, then we have predictiveness. Yes, no. I'm writing, hope you are able to see. So here we have a training data set of 6 instances, 1, 2, 3, 4, 5, 6. Then we will be preparing the decisions terms of out of these four attributes: CGPA, interactiveness, practical knowledge, communication skills. So based upon that, job profile will be created. Here CGPA, first one is having CGPA greater than or equal to 9, and interactiveness is yes, then practical knowledge is good, communication skill is also good, then job profile is yes. Then second one is having CGPA less than 9. Interactiveness is no, practical knowledge is good, communication skill is moderate. Then also job profile is yes. Third one is having CGPA greater than equal to 9, then interactiveness no, practical knowledge average, communication skill moderate, then job profile is no. Then you can see for each one the attributes are written over here, and the job profile is written as yes or no. For this data set, we will calculate and we will have the final result. So here I have already told you the final prediction will be prepared on uh, weights. So weight is applied here. How we can apply the weight for calculation and getting the final prediction, we will see. So as here total 6 data instances are there. So our first weight assigned to each item will be 1 by 6. How we can write this? And in step 2, we will iterate for each weak classifier. Strong and weak classifier I have already told you in the previous class. Here we will be seeing the weak and strong classifier. Based upon that, we will be calculating the weights and all. Then our first decision stump will be on the previous table we have seen, plus CGPA. First, we will take this. Then, when we are taking the decision stump, then we will repeat the step 2. Then, according to step 2, first we will take the decision stump. CGPA. This will denote on the training data set. OS we will be using the full training data set. The data instance will be else no. We will prepare one another column as predicted job offer here with the previous table as we are taking CGP as first decision stamp. So here we will write CGPA then predicted job offer. I have already told you how predicted job offer can be written. And already we have actual job offer. Then we are having initial weight. This is greater than equal to 9, then we will write here yes. It was less than 9, so we will write no. Again, greater than equal to 9, we will write yes. Less than equal to 9, we will write no. And the actual job offer was already written in our training dataset. Initialize the initial weight. So 6 data instances are there. We are writing here weight as 1 by 6. Then we will move on to second step. Step 2 of B. From this table, you can see that predicted job offer and this actual job offer is not matching. So it's misclassification. So we'll compute the computed error for this first term CGPA. Otherwise, we will not compute. It will be the weighted error we will compute. And write it like this. So the summation here from 1 to n. Child is with region. If so, y dg is 0, then it's correct prediction. If then it's wrong prediction. I have shown you in this table was actual and predicted is not matching, so not correctly classifying. So now we will compute the weighted error. Now we can compute it using this formula and applying here two. These two are not correctly classified, so we will take 2 into already we had the weight into 6, but we will get this. So we will get the weighted error. Then in step 3, 2 of C, we will compute the weight of each classifier. So one formula is there to calculate it. Alpha CGP of log. Yes, we have already calculated the weighted error. Divided by weighted error. Then we put this value. As we calculated it in the previous step. We will get 0.347. So it will be the weight of each weak classifier. After this, we will let the normalizing factor. Which is Z CGPA equals weight of correct classified instance into number of correct classification to e to the power minus alpha CGP. What's weight of wrong classified instance or of wrong classification to e to the power plus alpha CGP. So we will put all the values in this formula. We have seen that wrong instances are these two. These two are wrong instances. So 2 and other 4 are correct instances. So we will write correct classified instance weight will be into number of correct classifications 4 e to the power minus 0.347. It was already calculated as weight of each weak classifier. Then 1 by 6 into 2 wrong classifications were there. This value we will put, and after calculating all these, we will get 0.9. So this will be your normalizing factor. After that, we will update the rate of all data instances. Step 2E. So we can calculate like this. So it was the weight e to the power minus 0.347 divided by 0.9428. We are just putting this value here in the calculated weight of weak classifier here. The weight, originally what we assigned the weight, so this we will write, and after calculating all this we will get 0.12 colon. This we calculated for correct instance. Correct instance. Similarly, for incorrect instance, we will also calculate like this only. Just directly we are putting the value. This is for incorrect instance. So we have come upon the weight calculation for all the data instances. This we will update in the table. Already we have written this like this. I will not write again this. It will be same as the previous table only. Only we are updating the weight. This will be same only like the previous. Here only we are updating the weights. So it was correct instance as it was yes and yes. It was incorrect instance no and yes. It was also incorrect instance yes and no. It's correct instance no and no. Then yes and yes, yes and yes. So that's why we are putting these values same for correct instance and this for incorrect instance, which we have just now calculated and we are updating in this way in this table. Next we will take second decision sum, which I will take from the very first table where I have shown you, which is interactiveness. Likewise, we will make this table as like this. It was given in the very first table. We will write here. So as I have shown you in the first decision stem, how we have written the predicted job offer. So we have to train the decision stem. If interactiveness is yes, then the data instance is predicted to have job offer. Yes. If interactiveness is no, then job offer will be no. Here, like that, we will write the actual job offer was as it is, and our weight was from the previous calculation. So for this second decision term, we are preparing this table, and similarly, we will compute the weighted error for this decision term, like the previous one. I will write everything. On the previous thing only, we are writing this using that formula. Just I will write the value. It will be calculated like that only, what I have shown you. So we are getting this weighted error as 0.2501. One we are writing as from this, only one is misclassified. The second one was no, no only. So it was here, no and yes. So we are writing it 1 into 0.2501. If it was 2, then we would have write 2 into 0.250. Then similarly, we will calculate the weight of each weak classifier. This also I have shown you in the previous calculation.
Sir,
Yeah,
sir, I have doubt in step 2B. Why you have not written 2? You have written only 1. Because there are
yeah,
two
this
values.
I have already told you. This here it's misclassification for this one case. So we are writing 1 into 0.2501. If it was both here also yes, no or no, yes, then we would have write 2 into 0.2501. Like that we will write
Sir, then the value should be 0.1249
this level.
for, for NN case.
Here for this n case only, this 0.2501 we have to write. It was calculated in the previous step. I've already shown you that for the incorrect classification, we were getting that 0.2501. So that's why we are writing it here. And similarly, we will calculate the weight of each week classifier using this formula, which I have already shown you. Here we will be applying this. Finally, we will be getting this value. Then similarly, we will calculate normalizing factor. Using that same formula, we will calculate it here only. So correct classified instance value, we are putting it here as 0.1249 into 4 instances were correct. Then one instance is here is also correct, and one instance is wrong. So that's why we are writing into 1. Both no and no was there, so that's why we are classifying it as correct instance, and these 4 are already correct, and this one is only incorrect. After calculating all this, we will be getting the value. It's 66. So finally, we will update the table for all the data instances like the previous one. This is for correct instance. And this is with the weight of 0.2501. So it is also the correct instance. And one was your incorrect instance. For that incorrect instance, we will calculate like same way. And then after that, finally, we will update the weights in the similar way in the table. This will be interactiveness. This will be predicted job offer, actual job offer, then the updated weights 0.032, 5001. Finally, we are updating the weight of all the data instances for the decisions term interactiveness. Next decisions term is your practical knowledge. So in the similar way, we will find out how it is yes or no, how we can predict it. So practical knowledge is good. Good. Then data instances is predicted to have job offer. Yes. If the practical knowledge is average in this case, it's written in the previous table. Then we will write else predicted job offer will be no. So we'll update this in the table. It was already given. For good, it is yes. Good, yes. Average will be no. No. Yes, and yes. An actual job offer was given to us. Was yes, yes. No, no. Yes, yes. And the weights will be like previous in from the previous table only. So here you can see there is no misclassification. So for predicted and actual job offer, it's yes, yes, no, 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 yes, 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 yes. So we will not take this decision stem as it is correctly classified. So practical knowledge is correctly classified. So we will move on to next decision stem, which is communication skill. Again, we will see like the previous one more how complete calculate this based upon the communication skill. If it is good, then job offer will be yes. If it is moderate, then it will be no. So communication skill and this we will write in the table like the previous one. So moderate, it's good, moderate, moderate. So what will be the predicted job offer? Then we will write here yes, no, no, yes, no, no. The actual job offer was yes, yes, no, no, yes, yes. And the weight was like from the previous table only, which was 0.83 to 0.501. This was we assigned the weights from the calculation. So you can see here there's Mills classification. Then we will compute the weighted error. The communication skill is 1 into 0.5001 plus 3 into 0.0832. So misclassifications were One was this, second one, and this 3, which were having the weights 0.0832. This was having weight 0.5001, and this was correctly classified. This was also correctly classified. So we will not include them. Now after calculating, we will get the value 0.7497. Then again we will compute the weight of each weak classifier like the previous one. For communication skill, here I will directly put the value. I have already shown you how we can put. In this we will get the weight of each weak classifier. After that we will calculate the normalizing factor. This you just calculate yourself. Maybe the values may be incorrect. You just calculate by yourself while solving this. I'm just showing you the steps how we can calculate and how we can predict. I'm not going into the calculation. So from the previous table only, we are taking this weight of classified instance of correct classification and incorrect classification.